under this, and each organization is dedicated to work on the different parts of the Earth system. And specifically, NIOT is mandated to develop, innovate, develop, demonstrate, and transfer the technologies associated with the deep oceans. Like that, different organizations under MOES are involved in different activities connected to our mother planet. So in this aspect, NIOT is developing various technologies connected to blue economy. As you know, blue economy is very important from the nation of India. The ocean mission is going, in which Samudarayan is a very important vehicle, and you can see dependence of foreign countries. So to explore this one, Government of India has given a very ambitious program called the Deep Ocean Mission, which is a time-bound program which has 6 verticals, including the deep sea mining and the manned submersible, ocean services, climate services, deep sea biodiversity, ocean survey and exploration, energy and freshwater, and marine stations. Basically, all these verticals are aimed in exploring the oceans. So developing the knowledge about the ocean. So this is the first of its kind of initiative Government of India has given, which has towards the blue economy. So coming to the NIOT's manned ecosystem, the thing is that NIOT is not given the task of directly developing a human submersible. NIOT, after 25 years of experience, having developed a lot of unmanned vehicles for 6,000 meter water depth, now the task is to put man under the ocean up to the deepest part. The journey started with the development of unmanned vehicles, which is called the ROV. The item to the left is called the remotely operated vehicle, and the other one is called the shallow water vehicle. These vehicles have gone to deep ocean, to the surface, and to the polar. So every part of the planet this has got touched. In line with this development, we are developing this Matsya 6000. So you must understand what is an unmanned vehicle. This is an unmanned vehicle which is developed by NIOT and it is operational for quite few years. Basically, this is an unmanned underwater vehicle which can go down up to 6 kilometer water depth and depth into the deep ocean. And basically, it has gone up to 40-50 dives in the deepest part of the ocean, and it has found out a lot of new discoveries and anxious things. After this development, we developed an autonomous underwater vehicle. As you know, autonomous underwater vehicles is powered by artificial intelligence. Artificial intelligence is important to the vehicle, and this vehicle can be continuously there underwater for 48 hours. And it can go up to a depth of 6 kilometers, and it can go in the path which is programmed, like your autonomous cars, Google cars, which can go in the trajectory what you can come, like that. Under the deep ocean, where there is no GPS signals, where there is no communication, in all these places, it is designed in such a way that it is designed to explore the deepest part of the ocean. You can see the trajectories are made. The pre-planned trajectories can be made, and the vehicle will be able to follow the path and complete the expedition and come back with the results actually. So one important work this autonomous underwater vehicle did is that you must be knowing that aircraft, the Indian Air Force aircraft AN-32, which went missing in the Bay of Bengal at 3,000 meter water depth, this was found using this thing. And India should be very proud of this, detection in the deep ocean, because at this great depth of 3,000 meters, none of the countries in the world identified the aircraft at such depths. It's only a consortium of companies, consortium of various countries which joined together, synergized effort and found out. Basically, as India as a single country went ahead in identifying this lost aircraft at 3,000 meter water depth, and you can see the different pieces of the aircraft, which is located as a debris actually. Basically, this is used to find out the root cause for the failure for the Indian Air Force. So now coming into the evolution of deep diving system, everybody must be curious on understanding how the technologies got developed. It is not developed overnight, this technology. So the journey for this underwater exploration started in the year 1940s, where, scubas were made. Scuba is something, a pressurized suit where people will have, and they will have oxygen and they will dive into the ocean. Then after that, a gamut of technologies came, which enabled the human beings to dive down. Even though remotely vehicles are there, man has the interest to go everywhere into the deep ocean and see physically what's happening there. For that, different types of technologies were developed, and you can see from 1940s the journey started with the depth of 100 meters. Slowly the technology evolved, and now humans are able to explore the ocean at 11 kilometer water depth, which is the Mariana Trench. So in order to cope up with these developed countries and to explore our ocean, we have developed this submersible Matsya. You can see how the evolution have come. It has started right from the deep diving suit, then to the diving bell, and then to the submersible, and then there are submarine technologies which are much evolved, which can be in the ocean for several months together, applied for scientific research as well as for defense applications. Now coming to the deep submersible Matsya 6000, what's the difference between a submarine and the submersible? You must be aware of that one. So the submarine is used only for shallow waters. The submarines will be larger, carrying more people, something like 60, 70 people, only up to 400 meters water depth, mainly for defense surveillance application. But for us, the need is to go to very deep water for mineral exploration, and therefore we need to dive up to very deep waters for carrying out the exploration. So this vehicle, Matsya 6000, Samudra and Matsya 6000, is developed under the deep ocean mission. Okay, basically it is a underwater vehicle with no connection to the top. There is no cable connecting. That is making the submersible more challenging, and moreover we have to go down for 4 hours and then come up for 4 hours. This is the biggest thing. So we have to make ultra safe. We have to ensure the safety of the crew is ensured, and accordingly the engineering system has to be designed. So basically, if you see Matsya 6000, the capability is down to 6 kilometer water depth. 3 people will be sitting inside a compartment called the human cabin. Then it will be 10 kilometer long and 3 meter wide vehicle, and the humans there will be provided by life support system, because in water there is no oxygen to breathe. So there will be a closed chamber in which the people be inside and they breathe the oxygen and do this one. Then there will be a lot of engineering features, basically like an electric car. It's a battery powered vehicle where the submarine can be there underwater for 12 hours. So this is designed with a high level of safety and integrity, so that people will go safely and come back. So now what new we claim? So you see the journey of underwater submersible development. You can see this started in the year 1960, where America developed the submarine to go to deep water. As you all know, necessity is the mother of invention. So invention just didn't come like that. Necessity. So what happened is that during 1960s, you know about the sinkage of the Titanic ship. To identify the root cause of the Titanic, the submersible has to be developed to go down and see the root cause. For that, America developed. Later, various countries developed this one. They are called first generation, second generation, and the third generation. And what happened is that the third generation was more focused on developing the submersible for going down up to 11 kilometers in the ocean, which is very challenging. And presently, I am very proud to say that India, by indigenously developing the fourth generation human submersible called Matsya 6000, and you can see various features on the right, 11 features on the right, which claims that it is which speaks herself that it is a fourth generation manned submersible. So the main thing is to ensure safety of the crew, so that he safely goes down, completes the accomplished task, and come back. So this is the thing. So now presently the submersible is under development, and it is undergoing qualification in stages, and it will go for scientific exploration in the year 2027. So there are many critical technologies in this. How to withstand the pressure, how to withstand low temperature, how to overcome the communication, how to establish communication, how to position, how to identify your position, so that you should have reapproachability. If you find a new discovery in the ocean, you should be able to go to the place again and come back again safely. So for all these things, there are various technologies. And finally, if there is an emergency situation, then you should be able to come up safely. All these technologies are new to India, and now Minister of Earth Sciences, with the help through NIOT, we are mastering the technology for doing this one. So the main component of the human submersible is the human cabin, where 3 people sit inside and protect them from pressure from which they see outside. And using like a pilot of an aircraft, they will operate the submarine in all degrees of freedom, for which the human cabin is very important. And you know, India and Ministry of Earth Science and NIOT is handholded by various organizations, including ISRO, DRDO, and all the other organizations to achieve this, massive objective. So what happens is that while undergoing a series of qualification during February 2025, the last year, early this year, we underwent a harbor test to qualify the submersible for that basic conditions. Submersible was kept in the surface floating condition to assess the various performances for life support, power systems, control systems, habitability, etc. And it dived up to a few meters underwater. In all these things, various anomalies were found, and all these things were rectified. Now the system is getting ready for the dive, deeper dive. Now you can see a short video. This is how, the deep water submersible. So after carrying out an assembly inside the NIOT campus in Chennai, this submersible was taken to the port, actually, to the port in Chennai, which is called the Kattupalli port, and there the initial preparations were made. The human cabin inside, where 3 people reside, these oxygen supply systems are verified and its integrity is confirmed, because we need to oxygen supply, carbon dioxide removal at the thing. So once this is done, all the engineering equipments for propulsion, maneuvering, communication, all these things are mounted, and the submarine. This is a submarine without the flotation element. This is called the Mission Control Center, where we can see our pilots, remote pilot and the submarine pilot will be there, and the flotation test will be done. Flotation test will enable the submersible float on the surface, and it should be stable. These are all the stability tests done. So once the stability test is done and the system is qualified, then the man will embark. You can see these 2 gentlemen. These were the people along with me, came inside the submersible for the first dive. You can see the Indian flag on this one. And later, once the integrity is proved, the flotation along with the thing was lowered from the port crane. And because this is being the first of its kind exercise, all handholding was done, including the Indian Navy, who were around to ensure our safety in case of any eventuality. You can see the underwater visuals which were captured by the Matsya 6000 when it is underwater. Basically, all these things are, and you can see along with me are the 2 pilots who are the aquanauts. They are similar to the Gaganyaan crew. Actually, it is underwater. So once it is done, the systems used for diving inside the water, called the main ballast system, which will enable the submersible to go down and up. So that was qualified. And after that, you can see our very senior people in the ministry, they were participating in the dive. Once this is done, the submersible was done with the maneuvering test. Maneuvering test means like a baby walking in the trying to walk. This maneuvering turn will be done with acute safety, and the performance will be monitored. You can see our ministry, our director, and the secretary of the Ministry of Earth Sciences, who embarked this Matsya 6000 during the qualification. So during this exercise, all the critical systems of the submersible, like the mission, we call it as 2 categories. One is called the mission critical systems. The other variety is called the life critical systems. So during the February test, all the mission critical systems were qualified, and all the minor issues which were prevailing were rectified. And after completing this human dive, you can see the pilots and the crew coming out of the submersible. This is called the hatch, where people come out, and this is the first dive which was flagged to the nation. First human dive which was flagged to the nation, actually. So this is a Matsya 6000 team which developed the submersible, and it is developing the submersible, and a L&T facility was used for this purpose. So what is the way forward? Now we have completed the surface qualification of the submersible, and now by this coming April or May, we are going to take the submarine to the depth of up to 500 meters in the Indian Ocean, and we are going to qualify the submersible. And later, we are going to graduate in steps down up to 6,000 meters. So later, by the year 2027 and 28, this submersible will join the elite club of nations, 5 nations which have this kind of submersible. So the not alone MOS NIOT is doing, is a mammoth effort which is supported by ISRO, very organization of ISRO, Indian Navy, DRDO, CSIR labs, Indian universities, and other international suppliers. And not the least, there are totally 31 organizations are involved. Foreign companies are involved in the supply of our equipment. 19 Indian organizations are involved, and 10 companies which are import facilitators are facilitating this Matsya 6000 development ecosystem. So now the system is ready, right? The equipment is ready for a dive. Who will dive? Because people have to believe the engineers, right? So for this, deep dive experience has to be gained, because before we want to drive a car, you are going to a driving school to drive a car, to get on to learn how to drive a car. Like that, we identify 2 people, one from NIOT and another from the Indian Navy. So these people were subjected to various psychological tests. 3 tests were conducted for them: the physical test, physiological test, and the cognitive test. And these 2 people only qualified these tests, and they are now in the stage. So these people, these 2 aquanauts, were sent to France. So France has a similar deep water submarine called Nautil. So under the Indo-French collaboration, these 2 people, aquanauts, dived inside the submarine and then went down up to a depth of 5 kilometers into the Atlantic Ocean. So these 2 people are the only 2 people in India who have dived in the submersible up to such deep depths actually. So the submersible expedition started from a place called Porta near Portugal, and it went up to Horta, where the depth is something around 5,500 meters or 5,400 meters. There, the French pilots gave control to these pilots, and these 2 pilots operated the submersible, carried out various intervention activities, and those things you can hear from them actually. And then these are the photos showing the Nautil submersible of France, and you can see our people along with the French pilots. They were doing this one, and to the left bottom you can see these people planted the Indian national flag at 5,500 meters in the Atlantic Ocean, showing our presence worldwide. So these expeditions along with the French people in Nautil had a lot of takeaways actually, including how to plan a mission, how to make it safely, how to dive, how to come back, how to follow a mission, how to follow the communication protocol. Like that, various takeaways were there, which will empower our Samudra and Matsya 6000 mission. So thanks for everyone who are watching this meeting. And now I will try to show a video. So now there is a short video about our people diving in Nautil submersible. So this is about the Nautil submersible. There is an organization called IISF in France, like NIOT in India. So this is a first deep dive up to 4,000 meters, in which Mr. R. Ramesh, he is basically an experienced electronics engineer and a pilot. He participated in the first dive, and you can see the submersible being launched from the French ship actually. So it is a big process ensuring the human safety, and the submersible is launched from the aft of the ship. Now you can see the internal of the human cabin, where various parameters will be monitored. All the control and communication and the maneuvering of the submersible will be done from the human cabin, where people sit inside a thick metallic shell which is 2.1 meter in diameter. The volume will be equivalent to that of the Maruti 800 car, but the occupational thing is very less. You can see the mission control center in the ship, where communication happens between the Matsya 6000, Nautil and the ship. So normally the communication is only through acoustic, because electromagnetic waves cannot go there. So it is only the acoustic communication which is going to help them in communicating with the ship. Basically, communication has to happen every 15 minutes, in which this is the Indian flag and the French flag, which is dropped at 5,000 meter water depth into the Indian Ocean, into the Atlantic Ocean. So these are the various underwater visual you can see. So these are the robotic arms which is outside the submarine, wherein the pilots from the inside operate this external object using this manipulator or the robotic arms to carry out scientific intervention. samples will be collected from the sea floor at depth. The samples which are collected from such depth, speaks about the history of our planet Earth. So see, these are all the ecosystem. During the next dive up to 5,000 meters, this is Mr. J.P. Singh, who participated in the dive up to 5,000 meters. So basically, he is, pilot of Indian Deep Submergence Rescue Vehicle. Actually, after his tenure in the Indian Navy, basically he joined here as a pilot here, and we are happy to have him here because his experience from the Indian Navy has brought in a lot of knowledge. You can see the viewports where people peep through what is happening outside, because all others are opaque. Only these three viewports will be there to see what is happening outside the submarine. Because the concept is seeing is believing. So they were seeing a lot of features, and all these features which are seen in the very deep ocean will be recorded. And you can see the underwater operation also. So these are the underwater operations which are seen using the cameras mounted on the submersible. What is happening outside? So this intervention will be done, and once the mission is completed, this submersible is being retrieved. You can see the submarine will come and float on the sea surface. So the divers will embark the submarine, they will connect it to the ship crane, and the submarine will be brought back to the ship. Once it is brought back to the ship, the chamber, the human cabin will be opened, and people will come out of the nautil. And you can see our two gentlemen. In addition to that, other scientists of NIOT also participated, senior scientists participated in the expedition to understand the system as a whole and to bring this capability to the Indian subcontinent on making such kind of missions in the future. Thank you very much for your attention.
Thank you very much, Dr. Vedachalam, for bringing out the deep ocean to the understanding of human. So now I would request the kids to interact with the panel and ask their curious questions, whether it can be how Gaganyaan is different than Samudrayaan, or any questions they have. So please ask the questions to the panelists.
So actually, before asking the question, so basically I am an engineering head actually, who is engineering the systems. So basically these two are the people who dived there. So they have got a real-time experience of diving in this Samudrayaan and Matsya 6000. So I think you can interact with them directly to hear the experiences from them. I invite both of them to the stage, please.
Very good morning to everyone.
A very good morning to all of you. As my group head has already introduced about me, I am Commander J.P. Singh. I am retired from Indian Navy now and joined the National Institute of Ocean Technology as a scientist. And I'll give an open freedom to you. You can ask question in Hindi, Punjabi, English from my side. Thank you.
पंजाबी हिंदी किसी पे पूछो युवन कम
So good morning. So my question is how it feels to go inside the deep sea.
So you will answer it? You can answer.
Yeah, it was very exciting to go first time in the submersible. But to make the country proud, we need to participate in the deep dive. So we have participated. It was very exciting.
Thank you, sir.
See, what happens is that as you go down into the sea, you will see a lot of pressure. Every 10 bar, we will have 1 bar pressure. So at that depth, the pressure will be so high that, if a human goes there, he will be crushed. For example, if you take a water bottle, 1 liter water bottle, we had the experience of sending that, feeling that actually in our unmanned vehicles. If you take a water bottle of 1 liter water bottle, it will go down to the size of a small water cup actually. What happens is that it will get compressed from omni directions and will become very small. So what happens is that, human given goes there, he will become like a Lilliput. He will become a Lilliput, but of course we cannot be alive, but the size will shrink to the size of a Lilliput. So pressure is that dangerous actually. So whatever they gone is inside the chamber, which is well protected from pressure. So they will not feel the pressure. They will be in a shut sleeve environment where, like here, he will be there, but outside the pressure will be huge. Yes. Hope that answers your question. So next question, please.
सर जब आप समुद्र में गए तो आपको डर नहीं लगा कि बड़ी मछलियां आ जाएंगी तो?
हाँ, ये बहुत अच्छा क्वेश्चन है, बिकॉज जब मैं कभी स्कूल में होता था मेरे पास भी ये डाउट होता था. तो बेटा इसमें ये है कि जब किसी सबमर्सिबल में आप डाइव करते हो तो उसमें बहुत सारे सिस्टम लगे होते हैं, जैसे नेविगेशन सिस्टम लगा है, कम्युनिकेशन सिस्टम लगा है. तो उससे क्या होता है, बहुत सारी साउंड वेव्स जनरेट होती है, आवाजें आती है, और उससे जब नॉइज आप देखते हो, जब तालाब में जाते हो पत्थर मारते हो तो मच्छियां दूर चले जाती हैं. उसी तरीके से जब हम डाइव करते हैं और जब हमारे सिस्टम चलते हैं, थ्रस्टर चलते हैं, तो ऑटोमेटिकली वो दूर जाते हैं बिकॉज ऑफ इंटरफेरेंस. तो इसीलिए एक चीज वो होगी. और जहां तक डर का सवाल है, कई चीजें ऐसी होती है जो एडवेंचरस होती है लाइफ में, और बहुत कम लोग होते हैं जो एडवेंचरस लाइफ जीना चाहते हैं. तो मैं शायद उस वक्त इसी चीज में था और इसलिए मैंने प्रोफेशन चूज किया था. और ये मेरी मतलब कि शायद 300 या 350 डाइव होगी. इट्स लाइक दैट. सो डर सबको लगता है, बट डर के आगे जीत है. हाँ, इट्स लाइक दिस ओनली.
Hello, sir. Good morning. My name is Dr. Renu Yadav, woman scientist, कुरुक्षेत्र यूनिवर्सिटी. सर मुझे ये पूछना है कि जैसे हम स्पेस की बात करते हैं तो हमारा जो स्पेस क्राफ्ट है वो वैक्यूम में जाता है, एंड वहां से जब पर्सन लौट के आता है तो उनके साथ थोड़ा फिजिकल चेंजेस उनको फेस करना पड़ता है. देन आप जब ओशन में गए तो वहां पे वाटर के अंदर आपने सरवाइव किया, तो उसके बाद आपको कोई चेंज फील हुआ, लाइक आपकी बॉडी में मेंटलिटी, लाइक जैसे स्पेस में होता है कि आप भूल जाते हैं, ब्लैंक आउट हो जाता है, वैसा कुछ, या सब नॉर्मल था?
Yes, ma'am. I perfectly agree. I'll answer in Hindi so that everyone understand.
Yes.
It's like कि मैम आपने देखा होगा कि we generally go into swimming, और आप देखोगे अगर आप बोट पे राइड लेते हो तो थोड़ी रोल पिच होती है, वॉमिटिंग होती है.
Yes.
उसके बाद जब आप आते हो तो आपको थोड़ा ऐसा लगता है कि मैं स्टेबल नहीं हूँ. सो इट लुक्स लाइक दैट कि कुछ अल्कोहलिक तुमने ले लिया है.
Yes.
तो सिमिलरली जब आप पानी के नीचे जाते हो तो मैं एटमोस्फेयर में ही रहता हूँ एट 1 बार. जो मेरा एटमोस्फेयर है 1 बार रहता है. जो सर्वाइबिलिटी के लिए मैं एक ऑक्सीजन कैरी करता हूँ, और CO2 स्क्रबर्स होते हैं जो CO2 को एब्जॉर्ब करते हैं. तो इन्वायरमेंट सेम रहता है, ओनली जो एक्सटर्नल प्रेशर है वो मेरी बॉडी के ऊपर नहीं, मेरी व्हीकल के ऊपर एक्ट करता है. तो मैं हमेशा 1 बार पे रहता हूँ, लेकिन रोल पिच होने से मेरी बॉडी में वो चेंजेस आती हैं. बट स्लोली आप एक्मेटालाइज हो जाते हो. जैसे आप फर्स्ट टाइम ट्रेन में सफर कर रहे हो, स्टेशन में उतर के आपको थोड़ा फील होगा कि यस आई एम डिजी. It happens with a human because, like sir has mentioned, we used to go for a physical, medical, physiological, medical and cognitive. Once you clear these 3 stages, then only you will be selected as a pilot. क्योंकि ये चीजें हर एक बंदे के लिए पॉसिबल नहीं है. कई बंदे वॉमिट करना शुरू करेंगे, कईयों को सी सिकनेस होना शुरू हो जाएगी. तो आफ्टर क्लियरिंग दिस वी गेट इनटू दैट एंड वी गेट एक्मलेटलाइज. अगर आपको लाइक माय कलीग्स दे हैव ऑलरेडी बीन टू अंटार्कटिका, but before going to them they get acclimatized to that particular environment. So space and this they have been same medical standards, but the only thing is that we are going under pressure, they are going below the pressure.
Right. Thank you, sir.
Thank you, ma'am.
हेलो सर, मेरा क्वेश्चन ये था कि ये जो सबमरीन है ये चलेगी कैसे? अगर बैटरी से चलेगी तो ये ह्यूमन बॉडी को नुकसान पहुंचाएगी, और सोलर पैनल तो समुद्र के अंदर चलेगा नहीं, तो कैसे चलेगी?
हाँ, सो ये जो व्हीकल है ये बैटरी पे चलती है, जिसकी एंड्योरेंस 12 घंटे की रखी है हमने. तो अभी जब ये बैटरीज है, ये जो है एक्सटर्नली कनेक्टेड है, ये अंदर नहीं है. जहाँ पे हम बैठे हुए इंसान वहां पे नहीं है, और ये सॉलिड स्टेट्स में है. हम कुछ भी डिस्चार्ज नहीं कर रहे हैं सी में. ये बैटरीज को हम ऊपर आके चार्ज करते हैं हवा में. जब चार्ज होती है, जब पानी में जाते हैं तो डिस्चार्ज करते हैं. तो इट इज नॉट गोइंग टू अफेक्ट एनी मैरीन लाइफ और एज वेल एज ह्यूमन लाइफ.
यस, अब कौन सा क्लास में है?
सर 7th है, 7 माय सेक्शन 7th है.
अच्छा ठीक है, तुम क्वेश्चन पूछो.
सर जैसे पानी के इतने अंदर तक आप जाते हैं, उसके बाद वो सबमरीन के अंदर आप सरवाइव कैसे करते हैं? उसमें कुछ तरीके?
ओके, सो सबमरीन के अंदर जाने के लिए टोटल 108 घंटे होते हैं. जिसमें 12 घंटे हम ऑपरेशन करते हैं। अगर 12 घंटे के बाद हमारी बोट में कोई डिफेक्ट आता है तो हम वहीं पे स्टॉप हो जाते हैं, और उसके लिए हमारे पास 96 आवर्स का रेस्क्यू टाइम होता है। अब इस 96 आवर्स में जैसे मैंने बोला, हम ऑक्सीजन कैरी करते हैं, CO2 स्क्रबर्स होते हैं, और इमरजेंसी राशंस होता है। अभी सर्वाइवेबिलिटी के लिए मुझे खाना भी खाना है, मुझे पानी भी पीना है, तो ये इनक्लोज्ड कंपार्टमेंट में हम कुछ इमरजेंसी फूड लेके जाते हैं ताकि 4 से 5 दिन हम वहां पे सरवाइव करें। अगर हमारे को 108 घंटे तक कोई रेस्क्यू नहीं कर पाता है तो यू विल डाई डाउन। 108 घंटे इज अ अपर लिमिट, आप पहले भी मर सकते हो। अभी अगर आपका CO2 पॉइजनिंग हो रहा है एंड यू मे नॉट सर्वाइव 30 घंटे, तो आप 30 घंटे में भी मर सकते हो। जो मैक्सिमम टाइम दिया है, मतलब कि आफ्टर एक्सपीरियंस, वो 96 प्लस 12 किया हुआ है, 108 आवर्स, सो दैट पीपल कैन टेक यू आउट फ्रॉम द ओशन डेप्थ। बट अगर आप नहीं निकल पाए उसके बाद तो डेथ इज एमिनेंट, बट उससे पहले भी आप मर सकते हो। लाइक मैंने मैम से डिस्कस किया, यू हैव गॉन थ्रू मेडिकल्स की आप वहां तक सर्वाइव कर सकते हो।
ओके, थैंक यू सर, थैंक यू महेश सर।
थैंक यू एवरीवन। बच्चों के लिए अच्छे से ताली बजनी चाहिए, अच्छे अच्छे सवाल आए। आई वुड रिक्वेस्ट द पैनलिस्ट टू बी सीटेड, प्लीज बी सीटेड। अब हम सेशन के आखिरी पड़ाव पे है, सो may I request Dr. Surya Chandra Rao, Director IITM, to come up on the stage and grace the occasion and present memento to our dignitaries. Thank you. Thank you everyone for participating in this session. Now the session will end, and in the main hall, Nari Shakti will continue. And for Blue Economy and Sagarika, the delegates are requested to move to hall number 13. Thank you.